Hello guys, I'm Ankit. In this video, we shall see another problem on LeetCode. Reshape the matrix. So the given matrix, and we have to reshape the matrix M cross N into some other R cross C matrix. So M is the first, M cross N. The first dimension here represents is row, and the second dimension which represents is column. So what do you mean by reshaping the matrix? Is let's say the matrix is 2 cross 2 here. We have to reshape it to 1 cross 4. So how do we know that 2 cross 2 means if we have 2 cross 2, that means 2 rows and 2 columns it has. 2 rows and 2 columns. So apparently this will be the square matrix. So in this 2 rows you have and 2 columns we have. We have to reshape this to 1 cross 4. So 1 cross row means 1 row. In that 4 columns. Only 1 row but 4 columns. So 1 row, 4 columns. That means if the elements are in order 1, 2, 3, 4, here it should be 1, 2, 3, 4. You have to fill in the elements from the original matrix to reshape matrix from in the row wise manner. So first row in that first column, second column, again second row, first column, second column. Fill in the order in the reshape matrix. So this is the task which we need to implement. So what is the approach to do this? And they have told it will be minimum of one length. So as you know, one thing we can confirm is if there are four elements in this matrix, the reshape matrix also should contain a size that should be capable of holding four elements only. So then only we can reshape the matrix from 2 cross 2 to 1 cross 4. Let's say instead of now 2 cross 2 we have. So in these four elements we have 1 cross 3 matrix. 1 cross 3 means 1 row, 3 columns. So this will be where we can fill only three elements, but we have four elements in the original matrix. We can't reshape it to one cross three. So how do we validate we can fill in the element from the original matrix to the reshaped matrix? How do we validate that? So that is from the dimension itself. We have the dimension 2 cross 2 means nothing but 4. 1 cross 4 is nothing but 4. So when this dimension matches, that means yes, you can fill in all the elements from the matrix to the reshaped matrix. But in this case, 2 cross 2 is 4, 1 cross 3 is 3. So that means you have 4 elements, but you can fill in only 3 elements in the reshaped matrix because the dimension of the reshaped matrix they have given is 1 cross 3. If we have 1 cross 4, yes, we can fill in. So before beginning of filling the elements from the matrix to the reshaped matrix, first we need to validate whether M star N is it equal to R star C? If it is not equals to, then yes, you cannot perform the reshaping here. So that is the first condition which we need to check. If this condition satisfies, in this case 2 cross 2 is equal to 1 cross 4. So if this condition satisfies, then how do we fill in the elements from this matrix to this matrix? So I have taken this example now here. So we have, this is nothing but 3 rows. So 3 cross how many columns? 2. So 3 cross 2 matrix. Here in this case row is 2. So 2 cross and number of columns is 3. 3. So again I'm telling this indicates row and this indicates column. Number of rows, number of columns. If you see 3 cross 2 is nothing but 6. Again 2 cross 3 is again nothing but 6. Yes, that is matching. So that means you can reshape the matrix from 3 cross 2 to 2 cross 3. So you have the elements, 6 elements. Here also you can fill the 6 elements. So how do we perform the operation? So what we do is we start iterating over all the elements in the original matrix. So run the loop. Two for loops we have to run inside, as you know. Right. So from this matrix to this matrix. But how do I replace the element? If you run the loop from in the matrix, as you know, this is a 2D matrix. So two for loops in the loops when you have nested loops. How do we put in the elements from this matrix to this matrix? So what do we do is you are for sure that number of total elements will be six. Total boxes what you get. That is cell 1, 2, 3, 4, 5. 6 cells you have in the matrix, original matrix, and 6 cells you'll be having in the reshape matrix. So what we can do is we run the loop. No? First element you check here. You get this. Okay, I'll mention 0, 1, 0, 1, 2. And here is 0, 1, 0, 1, 2. So you take 0, comma 0th element, that is 1. And you have to fill into 0, comma 0 in the original matrix also. So from 0, comma 0 to, it has to move to 0, comma 0. Next, from 0, comma 1, it has to move to again 0, comma 1. Next, 1, comma 0, it has to move to 0, comma 2. So is there any pattern we are observing here? No, there is no such patterns. What we do is, when you find 0, comma 0, you put that in I, comma. In the sense, what I mean here is, I'll just erase all this. So what do I mean by that is, okay, now we are iterating over the original matrix. We'll, for the reshape matrix, we'll have row. Okay, we'll have row, initialize it to 0, and column also, initialize it to 0. Let this be R and this be C. Initialize both row and column to 0 because we will be having 0, comma 0 value for sure because they have told in the dimension, right? So this resulted minimum one cell will be there. So 0, comma 0 will initialize. Now you find this element 1, 0, comma 0. Check whether 0, comma 0, like you have the row that is less than R and column that is less than C. This row and column is a specified dimension. Here row is nothing but 2, column is 3. Okay. Initially we initialize row equal to 0, column equal to 0, and the given row and column dimension of R cross C is nothing but 2 cross 3. So 2 is row, column is 3. In the original R was 3, column was 2. Now check whether row is lesser than R. Yes, it is lesser than 2. So that means yes, you can fill in the value at reshaped of row, comma, column. Yes, it is less than 2. We are not checking for row. We check for the column. Is it less than C? Yes, 0 is less than 3. So that means yes, you can fill in the combination of 0, comma 0 in the reshape matrix. So from here, it will move here. That will be equal to nothing but the matrix of I, comma j. See, I, comma j is a loop running for this matrix, I, comma j value. And we're putting 0, comma 0 element in 0, comma 0 position in the reshape matrix. How? By checking whether the column value 0 is less than 3. Yes, it is. Okay. Next, you move to this element. So again, 2 we have. So now what we need to do? We have to increment the value of column now. So column will be incremented. Because next column you have to move in the same row. Now again check. Okay. So column will be incremented to 1. So row initialized to 0, column initialized to 0. So column got incremented to 1. Now check whether 1 is less than 3. Yes, you insert 2 into the 0, comma 1 position. Again increment column, so column will become 2 now. Now you move for this position, right? This element 3. Now check. 2 is less than 3? Yes, it is. That means you add the value at 0, comma 2 position, row, comma column. So 0, comma 2 position, that 3 will be assigned. Next you move to this element. So again column value should be incremented to 3, no? Yes. Before once you insert 3 here, column value will get incremented to 3. When you insert 4, here you could say 0, comma 3. But 3 is not less than 3. That means, yeah, this row is over. Done. Now you have to move to next row. So if in case before inserting only, you have to check here, you have to check before inserting the value. If in case column is equal to C, that means row should be incremented. So the logic what we are doing is we keep on putting values on the column. Once the column value get exceeded of the given value, you increment the row. Move to the next row. So now row will be incremented and reinitialize column equal to 0 again. So column would become again 0. Got it? So we start iterating over the elements in the original matrix. And you put elements in the reshape matrix column wise. Keep on putting the element column wise, increment column value. But every time you have to check whether the column value which you are pointing to is equal to is greater than equal to column, given column is crossing the index. If it is crossing the index, then we have to that if is that we have to move to the next row. So next row we want to do we have to increment the row and column should be reinitialized to 0 because in the second row we have to put the elements in the first column. That's why column is reinitialized 0 and row should be incremented. Now row is 1, column is 0, 1 comma 0 comma. Yes, you insert 4. Now again column plus plus you have to do. So column will get 1. So this code has to be before to assigning the values. So before to this. Okay. Next you have 5. Again check whether 1 is less than 3. Yes it is. So insert 5. Increment column. Next 6. 2 is less than 3. Insert 6. So again increment. Yes, that is okay. And you might ask, row will not be out of dimension. No, it will not be, because before we are proceeding with this task, we will be checking the dimension is it equal or not, right? Number of cells in both the matrices are same or not. Here 3 cross 2 equal to 6, 2 cross 3 is also equal to 6. So yes, dimension will be equal here. 6 is the number of cells. Then only we proceed with this. Otherwise, we'll stop here itself. They are not equal. In this case, 1 cross 2 cross 2 is not matching 1 cross 3. So you stop. You'll not be performing all these operations. So if that matches only, then only we proceed with this calculation. So this is how we do the reshaping. We'll proceed with the writing the code. Then n equal to column size. So mat of will take one of the row dot size. Okay. So next we have to define a reshape matrix. So vector int. So here again inside that we have to write vector int. So it should be vector inside a vector because it's a 2D array, right? That's why. So let's name it as reshaped of size R, and the column will be vector int of C. Yes. So this is here defining the reshape matrix of R comma C. R comma C. So now let row be equal to 0 and column also equal to 0. Iterate over the original matrix. So now what we need to check? We have to check these conditions, right? So if column equal to C, then or greater than equal to 0, so fine. Row should be incremented and column should be reinitialized to 0. Otherwise, after that, what we do? Reshaped of row comma column will be equal to the matrix of I comma j. Then again increment the column. Yeah. So at last return the reshaped matrix. So we can run this now. Okay, it's giving wrong answer here. Let me check what I have did. So this was the first example. No, second test case. Yeah, I haven't considered whether the dimension are equal or not. I have to check this condition first, no? If they're equal, then only I'll proceed. So if m star n not equal to r star c, then yeah, it won't be a valid one. Since it's not a valid one, we will be returning what they have given in the question. If the output not be, otherwise output the original matrix. So in this case, you have to return the mat itself. Yeah, I hope now it works. Yes. And for Java also, same logic applies. You define the matrix, you check the dimension, new matrix, put the values. Yeah, we'll submit this. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with other video in the next session. Until then, keep learning. Thank you.